This problem is on a geometric progression. The problem is on the ability to apply the formula to look for the common ratio of a geometric progression. So the question is, the sum of the first two terms of a GP is P and the sum of the last two terms is Q. If the GP has n terms, the common ratio is, so we have the options. The options are A, P divided by Q, B, Q divided by P, and C, P divided by Q raised to power n minus 1, D, Q divided by P raised to power 1 over n minus 2. Now, to get the solutions to this, we'll write out the terms. So as you can see, the first term is T1 and the second term is T2. So T1 plus T2 equals P. So the first term is A and the second term is AR. So A plus AR equals P. The first term is A and the second term is AR, because the nth term of a geometric progression is given as Tn equals AR raised to power n minus 1 here. So this second term is n is equal to 2, so 2 minus 1 is going to be 1. So the second term is AR. Now it will interest you to note that Tn is going to be the last term. If Tn is the last term, then the second to the last term is going to be Tn minus 1. So that's going to be the second to the last term. So if the last term is Tn, then the second to the last term is going to be Tn minus 1. So we are told that if, the sum of the last two terms is Q. So the last term is Tn and the second to the last term, the term before the last term is Tn minus 1. So this is going to give us, now we can see this now. Now the last term is AR raised to power n minus 1. That's the n term, plus the term before the last term is going to be AR raised to power n minus 1 minus 1. Now we can check why this is like this. Now AR raised to power n minus 1 plus AR raised to power n minus 1 minus 1 must definitely go to be equal to what? Q. That is what we were told from the question, that the last two terms is equal to, the sum of the last two terms is equal to Q. So I'm going to call this set of equations A plus arrow equals P equation 1 and A arrow raised to power n minus 1 equation 2. Now if you open this bracket here, I'm going to have n r raised to power 1 minus 1. That's definitely going to give me n minus 2. So this is going to be n minus 2. So I can completely remove the bracket. So this is going to be a raised to power r raised to power n minus 2. That's for the second term. Just the term before the last term. Now from equation 1, you'll find out that the terms on the left hand side, A is common to both of them. You can see that A is common, so I can factor out A from there to have A into 1 plus R. So we have A into 1 plus R equals P. So we can move on to equation 2 and factorize. Then if from equation 2, you realize that A raised to power R, AR raised to power n minus 1 is common to both sides. So this is going to be So on factoring out a r raised to power n minus 1 from equation 2, we're going to have a r raised to power n minus 1 into 1 plus r raised to power minus 1. So that is the factor there. So what we're going to do is to work out, so let me call this equation 3. So this is going to be equation 3, and this is going to be equation 4. So work out equation 3 and 4 together. Now let's divide equation 4 by 3. So we have a r raised to power n minus 1 into 1 plus r raised to power minus 1 divided by a into 1 plus r close the bracket, equals q over p. So the a on the denominator and the numerator of the left hand side will cancel out each other, so we'll be left with, so we are left with r raised to power n minus 1 into 1 plus r raised to power minus 1 divided by 1 plus r equals q over p. Now the next thing I'm going to do is to separate the terms inside the brackets on the left hand side into partial fractions. So I'm going to have r raised to power n minus 1 into 1 divided by 1 plus r plus r raised to power minus 1 divided by 1 plus r. So let's go, we have this. So we get this r raised to power n minus 2, sorry, that should be r raised to power n minus 1, because this one we have here minus 1 into 1 over 1 plus r plus r raised to power minus 1 over 1 plus r. So the whole of this is going to be and take this form. So I have this r raised to power n minus 1 into 1 over 1 plus r. So what I did to the arrow at the denominator here, at the numerator here, is that I applied the law of indices. So that becomes 1 over r here. So we have 1 over r. Okay, let me write that in color. So I have 1 over r. So that's that one there. R raised to power minus 2 equals 1 over 1 plus r. So what I'm going to do is to take the LCM of this here. So I'm going to have r raised to power n. So what I did was to find the LCM of 1 plus r and 1 r into 1 plus r. So definitely the LCM is going to be r into 1 plus r. So when I factor that out, 1 plus r, when it goes into r into 1 plus r, we are left with r. R times 1 gives us r. Then when I divide r into 1 plus r here, when I divide by, I'm left with 1 times 1, I get this. So we can easily see that the r plus 1 here and the 1 plus r at the numerator, the r plus 1 in the numerator and the r plus 1 in the denominator can easily cancel out each other. So you can see clearly that on the left hand side inside the parentheses, the 1 plus r in the numerator will cancel out the r plus 1 in the denominator. So that will leave us with, so we have r raised to power n minus 2 into 1 over r equals q over p. So reversing the 1 over r in the parentheses back to negative indices, we are going to have r raised to power n minus 1 times r raised to power minus 1 equals q over p. So by applying the laws of indices, this is going to be equal to r raised to power n minus 1, sorry, minus 1
minus 1. So from here, this is minus 1 rather, not minus 2, and this is also minus 1. So that will give us minus 1 equals, so that's going to be equal to Q over P. So we end up with, so we have r raised to the power n minus 2 equals Q over P. So what we do is to find the nth root of both sides of the equation, n minus 2 roots of both sides of the equation. So we're going to end up with r equals Q over P raised to power 1 over n minus 2, not 1, n minus 2, n minus 2. So that's the correct. So the correct option is option D.